Hello and welcome back. In previous lecture, we talked about hydraulic system basic sketch and components. We have also discussed the basic operation model of a typical hydraulic system. In this lecture, we will talk about pneumatic system. We will also discuss the basic components as well as the mode of operation. So let's start with lecture number 7. Pneumatic system in brief definition is a system carries power by employing compressed gas, generally air or any other gases, as a fluid for transmitting energy from an energy generating source like compressor to an energy using point like cylinder with piston rod to accomplish a useful work. So if we go for system components, we have air as a fluid, a filter to clean the air before entering a motor driven compressor, followed by an air cooler and air treatment unit, then storage reservoir with pressure switch, and control valve to control the movement of the piston with shaft in an enclosed cylinder. The basing actuator is again a cylinder with a maximum force on the shaft being determined by air pressure and piston cross-sectional area. Operating pressure in pneumatic systems are generally much lower than those in a hydraulic system, just 10 bar being typical, which will lift 10 kg per centimeter square of piston area. So 16 centimeter diameter piston is required to lift 2000 kg load. So it is obvious pneumatic systems therefore require large actuators than hydraulic systems for the same load. If we start describing the process of how the pneumatic system operates, the valve delivering the air to a cylinder operates in a similar way to its hydraulic equivalent. However, one notable difference arises out of the simple fact that air is free and returning air is simply vented to atmosphere without any hazards or concerns. Air is drawn from the atmosphere via an air filter and raised to a required pressure by an air compressor, usually driven by an AC motor. The air temperature is raised considerably by this compressor, and also air contains a significant amount of water vapor. Before the air can be used, it must be cooled, and this results in the formation of condensation. So air compressor must be followed by a cooler and air treatment unit. Compressibility of gas makes it necessary to store volume of pressurized gas in a reservoir to be drawn on by the load. Without reservoir, a slow exponential rise in pressure results in a similar slow cylinder movement when the valve is first opened. The air treatment unit is thus followed by a reservoir, and then the air will pass through a control valve to control the cylinder movement whether up or down in the same manner of a hydraulic system. Now we will brief a comparison between the two systems, hydraulic and pneumatic. If we start with the fluid at the first parameters, in hydraulic systems, confined pressurized systems that use moving liquids. In pneumatic systems, confined pressurized systems that use moving air or gas. Both of them are confined. Hydraulic use liquids and or oils, and pneumatic system use air or gases. In terms of movement, no delays in force movement. Liquids are not very compressible, and this is an advantage. There is no delay in force movement, but in pneumatic systems we are facing delays in force movement because of the compressibility of the gas. The power source which is responsible for raising the pressure is a pump for hydraulic systems and a compressor for a pneumatic system. In terms of energy cost, we have medium cost for hydraulic system and high energy cost for pneumatic system. Rotary actuators. In hydraulic system, low speed, good control and can be stalled. However, in pneumatic system, wide speed range, but I cannot have an accurate control on the speed. It will be difficult. In terms of linear actuators, we are using cylinders with a very high force. In pneumatic system, we are using cylinders with a medium force. Controllable force, I can control a high force with high pressure in hydraulic system. The control in pneumatic will be medium and force controlled due to medium pressure. The system type is closed and open in hydraulic system. In pneumatic system, it will be open. And in the coming lectures, we'll know what is the difference between closed and open systems in hydraulic system. In terms of hazards and safety, leakage is dangerous and unsightly. It can produce a fire hazard, and for pneumatic systems, the main hazard I'm facing is the noise. Thank you, and see you next lecture.